In this unit, we look at exponential functions. So first, let's start with an example to show you how useful these things are and how they just kind of show up naturally. So I want to take this example of investing money, okay? So you got $10,000 and you get 5% interest every year. So how much money do I have after 5 years, 10 years? Let's develop this from scratch. So I got 10,000, it's year 0. Okay, and in year 1, I'm going to get 5% of that initial deposit, right? So we would have 5% of the 10,000. That's how much I have after year 1. So just say at the end of the year, they pay you your interest. We'll simplify it. It's a little more complicated than this, and we'll talk about compound interest later. But for right now, let's make it simple just to see where this exponential function pops up in the real world. Okay. So in year 1, I have 10,000 plus this. This should be $500 if I take 5% of 10,000. So I have 10,500. But I'm going to choose to write it like this. I'm going to do a little factoring. So let's factor out the 10,000. Okay, and I'll show you why. You'll see why we do this later. So if I factor out the 10,000, what am I left with? 1 plus, and then you factored out the 10,000, so you're left with the 0.05. So you have, at the end of year 1, $10,000 times 1.05, which would be the same as 10,000 plus your interest of $500. Either way, you get 10,500. Okay, and I'll show you why I'm writing that when I do year 2, year 3. So year 2, you're going to have how much money you had at the end of year 1. That's the 10,500, but I'm going to choose to write it like this. I'll show you why. And then I'm going to earn 5% on that amount that I had throughout the year. So that's 10,500 times the 0.05. Okay. And that would be 10,500 plus 10,500, 5% of that. So that's probably a bit over $500, that next interest payment. And now I'm going to write it, I'm going to factor out the common factor, which I know looks funny, but it's this. That's common to both terms, right? So I'm going to factor that out, 10,500 or $10,000 times the 1.05. And what does that leave you with? Well, you factored this whole thing out, so it leaves you with the 1. And this got factored out, so it leaves you with the 0.05. So at year 2, I have the 10,000 initial dollars times 1.05 times 1.05. Okay, so you might see where an exponent's coming into play here. All right, let's do one more time, and then we'll have our formula, I think. So at year 3, the end of year 3, I'm going to have the amount I had at the end of year 2, which is this $10,000 times 1.05 times 1.05, plus 5% of that amount. So that's $10,000 times 1.05 times 1.05 times 5%, 0.05. And now I'll factor the common factor, which you kind of get the hang of this now. I think you can probably see this is the common factor, and I factor that out. And this all makes sense when I write it simpler. So it's 10,000 times 1.05 times 1.05 times, factored that out, 1 plus 0.05. That got factored out. Okay, and then you can see this is just $10,000, the initial amount, times 1.05 to the third. Right? And this would be $10,000 times 1.05 to the second. There's 2 of those. And this, of course, would be $10,000 times 1.05 to the first. Okay, and you could write a little formula. You see where we're going with this. At year, this is what we like to do in math. We like to model things. At year t, or use variables, I could have a function. My $10,000 plus 1.05 to the t, input t. Okay, and this is our first look at an exponential function. What makes an exponential function? My variable is up in the exponent. Okay, before we've been studying like functions. We did a lot of polynomial functions where we had an exponent, but the exponent was a constant number and the variable was the base. Now we got something different. We have a base that's a constant and the variable is up in the exponent. That's a very different acting function. We're going to learn all about the properties of that now. Okay, so we'll come back to the application, but now let's simplify to kind of your standard exponential function, some base to the x. Okay, and the condition for base is it's greater than 1. And that's the first one we're going to study. We're also going to look at the base where the base is between 0 and 1. Okay, and those are going to be our two cases. So if base is greater than 1, then something happens. If base is less than 1, we're going to look at the other case. Those are the two cases. So those are conditions for the number that's the base. Why can't the base be less than 1? Well, that would be, if I look at something like this, this is not included in our definition or our allowable bases, because this is going to act really weird. When you raise it, when x is positive, this thing's positive. When x is negative, then I just have, for example, if I raise like -2 to the second would be 4. But what's -2 to the -2? That's 1 over -2 squared, and that's 1/4. And I just get this really weird looking function. Okay, so it just doesn't follow the properties of an exponential function. So that's out. How come 1 is out? Well, 1, you notice 1's not going to be, it's either greater than 1, or we get down here, it's going to be less than 1. Why is 1 out? Well, that's a pretty boring function. If I looked at f of x equals 1 to the x, well, that's just 1, right? 1 to any number is 1, so that's a constant function. Okay, so those are my two conditions. All right, let's take a look at what happens in these cases. So if I just graph this thing, let's look at the properties of exponential functions. Let's plug in some values and see what we get as outputs. So let's see x, and let's see f of x. And if I see if you can do this, pause the video, see if you can figure out what the outputs are. You have to review your exponential properties. Do you know what 2 to the -2 is? Do you know what 2 to the third is? 2 to the -2 exponential property is 1 over 2 to the +2. So that's a 1/4. This should be a 1/2. Here's the one we'll see a lot. 2 to the 0, that's 1. 2 to the first is 2. 2 squared, of course, is 4. And 2 cubed is 8. So if I were to graph all these guys, I got 2 to the first is 2. 2 squared is 4. 2 to the third is 8. 4, 5, 6, 7, 8. And then going backwards, you see kind of what happens. You get fractions. So let's notice what's going on here. This is called exponential growth. We grow as x increases. We go really quickly. It goes fast. And as you go back, you'll notice my outputs are always positive. Even if I plugged in -10. What's 2 to the -10? That's a positive number. That's 1 over 2 to the 10th. That's a very small positive number, but it's greater than 0. So what we end up with is a horizontal asymptote on the x-axis. That's the line y equals 0. And we get this behavior called exponential growth, growing very quickly. And this is going to be true for any function. It's going to look like this for any function with base greater than 1. For example, if I just did 3 to the x, what happens? It looks a lot like this. That is x f of x. If I were to graph this real quickly, -2, -1, 0, 1, 2. Right, what happens? Well, 3 to the -2 is a 1/9. 3 to the -1 is a 1/3. 3 to the 0 is still 1, so it still crosses there. 3 to the 1 is 3. 3 squared is 9. 3 cubed is 27. So let's use a different color to graph 3 to the x. It still hits here, but it's going to grow faster. 1, input 1, output 3, input 2, output 9. Oh, let's try that again. 3, 4, 5, 6, 7, 8, 9. And then it's gonna go to 0 faster, but not that much faster. These will be smaller, but it'll still hug this line, have the same asymptote, but it'll grow a little quicker. So that guy's 3 to the x, and that's 2 to the x. You can see they have the similar properties, right? They're increasing. They have the intercept 0, 1. And if you change the base, they don't differ in their properties that much. They're just going to grow a little bit faster. Something I just noticed in my notes, I used B here and then I switched to A. All right, so let's just make a note of that. A and B are used the same thing. I should have just kept it at B. All right, so in the next video, we're going to look at what happens when A is less than 1.